Hello and welcome to Toddcast number 25. In this one, we'll go into the R and S configuration associated with chiral centers or stereogenic carbons. And this is going to be one of those things that might be weird at first, but the more you practice, the better you'll get. And in this Toddcast, we're going to do so many examples that by the time you're done, you'll see pretty much all the tricks we can throw at you. And your job, practice until it becomes routine. This is one of those things that is difficult at first, but when you start seeing it, the more you see it, the easier it gets. And I guarantee a week after you start into it, when you move on to other things in your organic chemistry studies, this will be one of the easiest things. It's a pain at first, but it'll be easy as you get into it. So, just like described in the previous podcast, a right hand and left hand are unique from another. So if you had to describe to somebody how you recognize a left hand and right hand, I know there's that trick where you say make an L, but if you look at the back of your hand, your left hand, it makes an L. But if you look at the palm of your right hand, it also makes an L. So it's not as easy as it may seem. You have to be a little more, I don't know, detailed and anal about it. So you have to tell people, line up your hands in such a way that you're looking at the back of your hands. Put your thumb in a 90-degree angle to your index finger. Straighten all your fingers out in front of you. And with your palms facing away, the one that makes the shape of an L is left. The one that does not, makes an inverted L, is your right hand. So I had to add a few extra details, the orientation of your hand and the direction they were pointing. And so that's the same thing we're going to run into when we do R and S. To describe them, we must orient them, and we must look at them in a very specific way. So absolute configuration, that's the name we give to it. It's the actual orientation of the structure. And it's had to come up with rules. So just like I had to describe how to look at your right and left hand, that would be the system for identifying the right and left hand. Cahn-Ingold-Prelog, three chemists, put together their set of rules. They got it together and we all sort of accept it. And so it goes sequentially as follows. Again, we're going to go with 4 unique atoms attached to a central carbon as what we're looking at. It is by atomic number or atomic mass, depending on how you read into it. So basically it works, you look at the atomic number of the first atom attached to a central carbon. If there are 4 unique atoms, if there are 4 totally different atoms, then you go by atomic number, highest atomic number. But in the case where you have isotopes, the higher mass isotope wins out. So you're going to notice I will change this as we go. So I'm putting heaviest atom to lightest atom. I will also write at some point from highest Z number to lowest Z number. Technically, we look at Z first, and when we have a tie in Z, then we look at mass for isotope. So both heaviest to lightest and highest Z to lowest Z, both are about 90% true. So I want to emphasize this. Okay, so let's go ahead and look at an example. So I have a central carbon right here. This carbon has attached to it a carbon with some H's, a nitrogen with some H's, no with an H, and an H. So there are 4 unique atoms. This one's going to be pretty easy. So as far as the periodic table goes, you have to know C, N, O, and H. Those are your common organic elements. So hopefully you know that the lowest atomic number is hydrogen at 1 atomic number. So that would be priority number 4. You also should know that carbon comes before nitrogen, comes before oxygen in the periodic table. You hopefully have seen C and O enough times that the periodic table just lays out for you pretty nicely. So my priorities will be 1 for O here, 2 for N, 3 for carbon, and then 4 for H. Okay, the issue we run into here is how do we align it? So let me get rid of my drawings. So second, we have to orient the molecule in such a way that substitution with the lowest priority, number 4, points behind the plane. So right here, number 4 is in the plane. So that's not the right orientation. That'd be like looking at your fingers and your thumb so that you could, the index finger is blocking all your other fingers. You have to rotate it by 90 degrees. Same thing here. The rule is rotate it so number 4 is pointing back. So if number 4 rotates to here, then NH2 will rotate there and O rotates there, rotate there like this. So now when I rotate it around, NH2 is now in front from and back. OH, which used to be in front, is now in the plane, and H, which is in the plane, is now in back. So 1, 2, 3. So I've aligned the right way. I put number 4 in back. And technically, I should be looking from this angle down that H bond, but this is close enough that's going to work out for me. So orient it with number 4 in back. That's the key thing. So it points behind the plane. Last but not least, draw a circle starting at 1. So that's incorrect because I did not go through substituent 2. So 1 through 2 to 3. So circles such as that. If it is clockwise, which it is, then we call it an R center. If it is counterclockwise, then we call it an S center. Okay, so let's try one more of those. Priority again, O, O, C, and H. So now I have a little bit of trickiness. 4 is H, it's the lowest priority, lowest atomic number. Carbon is going to be 3, but I have 2 O's, so they're the same in terms of the atom. So if you ever played the game of war with cards, where you turn cards if you're tied, what do? You keep turning. You go to the next round of cards. So the next round of atoms. So next to the O, we have an H. Next to the O, we have a C. C is higher priority than H. So an OCH3, it's higher priority than an OH. So priority 4, easy enough. You can recognize that most of the times, almost always H. Number 3 is methyl. As far as these go, the OCH3 beats the OH, 1 and 2. Okay, so first prioritize, check, done. Second, align the molecule in a way where number 4 is in back. Well, luckily, 4 is in back for me. So structure was already done. Sometimes we get lucky that way. And last, draw a circle from 1 through 2 to 3. So if I do that, it is counterclockwise. So in this case, it is an S center. So we would designate this as R. And so it'd be 1 amino ethanol. It'd be R. And then this would be, well, nomenclature-wise, we'll get into it, but 2-carbon chain, it's an ether, so it's an ethyl-methyl ether, but it's hydroxyethyl methyl ether, and then you put an S in front of it. Okay, got ahead of myself with nomenclature. We'll get to that as we go, but R and S, that's the key thing we're looking for. Okay, so you're either clockwise or counterclockwise, you're either left hand or right hand, you're either R or S. Okay. So getting your priority straight, the step 1 part, is actually harder than it may seem. So just like we saw in that second example, we had 2 O's. So we had a H, a C, and 2 O's attached to the central carbon, but the 2 O's were in different groups, so they were not equivalent. So we had 4 unique or 4 non-equivalent atoms attached to the central carbon. So I have the same situation here. We're going to look at this. If they're tied, list those atoms in ascending Z, look for the first point of difference. Let's see what that means. So in this case, this group here, I probably should start drawing my 4th substituent in just so I see it. So OH is in front, 2 are in plane, you have to have 1 more in back. So the H is in back, it's an assumed H. So my priorities are 4 for H, it's always stuck at number 4, and O is number 1 because it beats carbon and carbon. So O is number 1, H is number 4, and then I have a carbon and a carbon. So those are my 2s. So I need to consider my 2 carbons. So this carbon has 1, 2, 3 H's. This carbon has a carbon and 2 H's attached. So 1 and 4, easy to get. But when I look at the rest, I now have this one with a C right here and 2 H's. This one is 3 H's. So priority-wise, a C beats all the other H's. That's your highest card, your highest atom. So this takes on number 2. So this side is 2. This one takes on number 3. So I'm going to change that from, that stays 2, change that to 3, which means this is priority 2, this is priority 3. Okay, not bad. So let's try another one. So I'm sticking with the same basic structure. So notice this hasn't changed. So we're going to do the same thing. Going to have the H going back. Priorities again will be 4 and 1. Those are my freebies. So O is 1, H is 4, and then I have 2 carbons in the middle. Notice this same pattern because guess what? We see this a lot. Okay, so now I have 2 carbons and 2 carbons. So now it gets a little trickier. So when you have a double bond, you have to prioritize all your bonds. So this carbon has 1 bond to carbon, 2 bonds to H. This carbon has 2 bonds to carbon and 1 bond to H. I draw this in. There's an H and there's 2 H's. So fewer H's. So if I go ahead and put that out here, this one has a C, C and an H. This one has a C, an H and an H. So 2 C's beats 1 C. This is priority number 2. This is priority number 3. So I'm going to number them accordingly, 2 and 3. Not bad, going well. One more. And again, as it gets more complex. So this structure is very similar to this one. This, although it may not seem like it, is kind of the same thing. It's just I have a lot more molecule on each side. But no matter how big the molecule gets, the rules stay the same. Go one atom at a time until you have differences. So I need to draw my H and back as I did in the previous one. So I have an H and an O. Priorities 1 and 4 are easy as always. So OH is 1, H is 4. Got those. Now this carbon over here has 2 bonds to O and a bond to H. This one over here, 2 bonds to C and a bond to H. So I'm going to draw my H in right here just to be complete. So 2 bonds to O and a bond to H, 2 bonds of carbon and a bond to H. O beats carbon, so 2 is this group, 3 is this other group. So priorities can be a little bit on the tricky side. They're not hard, but you have to be systematic, get in a good habit. So I like to always say, before you can determine RNS, you got to get your priorities straight. So priorities, make sure you can put the right priorities, because then once you have it, it's easy. All these examples had number 4 and back. So R, R, and R. Kind of boring. So getting RNS is easy drawing a circle. Priorities make it the most challenging part. H also was in back, so that made life a little bit easier. So I could skip just to the final step. Okay, so priority matters. If you get really good at it, you can actually start recognizing patterns and determine your RNS fairly quickly. So those 3 examples we gave, and even on the first page, the way we rotated and the way one structure came in, number 4 is in back. 4 is in back, that's easy. If 4 is in front, we're supposed to rotate it in back, but we have a slight, I don't know, advantage we can visualize well. And so I ask you to think about the following experiment. If you're watching a clock with hands, a traditional analog clock, if you're in front of the clock, the hands are moving clockwise. But if you stand behind the clock looks wrong and the hands are going counterclockwise. So if you know that from the back of the clock, it's the opposite of what you should see, then you know you can reverse it to figure out what it would be if you were in front. So we're going to take advantage of that same notion and say that in this case, we'll do the same things before, make sure we have 4 substituents. So I have methyl, ethyl, bromine, and then the H. So this time number 4 is in front, so I could rotate it. I could rotate this molecule by 180 degrees and redraw it as such with Br in front, H in back, and that's great. But I've just spent a lot of time redrawing it, and every time I do a step, it introduces potential for error. So I'm going to say, let's not do that. Let's see if we can find a cool little trick. And the trick is going to be the following. Identify your priorities. So 1 and 4, the easy ones. Ethyl beats methyl, just like it did before. So 2 and 3. If I draw my circle this way, I will get clockwise, but if it's clockwise from the back side, then the front side would be the opposite. Go to the opposite side of the clock and the hands are rotating the opposite way. So although I expect it to be R because of that, it isn't. It's actually S because we are looking from the opposite side. So if number 4 is in back, take it as is. If number 4 is in back, draw the circle and just take the opposite. So rather than redrawing it, just going to take the opposite. So here's what we have so far. Here's our running list information. If number 4 is in back, take it as is, draw the circle from 1 to 2 to 3. Clockwise is R, counterclockwise S. If number 4 is a solid wedge coming out in front of the plane, then you're just going to take the opposite. So that's probably step saving, time saving. I like it. But then we get to the hardest one of all. If it is in the plane, if priority 4 is in the plane, then you have to do some work. And so I'm going to show you the traditional one, the one that 99.999% of all OCHEMs will teach you. And then I'm going to tell you I'm actually in the 0.001. There's a much easier way to do this. But here's standard convention. Priority number 1, the chlorine, highest atomic number. 2, oxygen, and then 2 carbons are tied, but double bond, a lot of bonds of carbon, just a methyl. So 3 and 4. So there's my chiral center. There's my 1 for chlorine, my 2 for OH, my 3 for that carbon, my 4 for this carbon. So number 4 is in the plane. So by convention, I should be looking down this bond with number 4 in back. So I can try it from a third person observer. That is what they teach you. Think about what somebody else looking at it would see. I don't agree with that method, but like I said, 99.999% of all organic chemists will teach you this way. Third person observer, think about what another person has seen. Okay, so if you do that, you have to rotate it. So if I look at it from the side, 1 is in back, 2 is in front, 3 and 4 in the plane, but for them, this is to the right, this is to the left. So they're going to see this differently. They're going to rotate it because I'm looking from the side, they're looking straight down. So if you have to rotate 90 degrees to get it to their perspective. So for their eye to come out of the plane and be in front of the page like mine, you'd have to rotate this like this whole structure. So if you did that, the 2 would now be in the plane over here on the left, the 1 would be in plane on the right, like I have here, kind of like, sort of like we did with the Fisher. The 3 is now in front and the 4 is in back. And I should probably have these closer together so they're blocked, but I wanted to show that 1 is in front, 1 is in back. So at this point, you could just draw the circle. 1, 2, 3, so we get an S. But you're supposed to rotate it up so that the 4 is straight back. So notice this come down an angle, not here. So to get it just right, I also need to rotate this 4 up and back, which brings that down to the plane and rotates these out slightly. So 1, 2, 3, again, is still counterclockwise. So counterclockwise means S. Okay. So if it's a dash wedge behind, take the circle as is. If it's a solid wedge, take it, reverse it. If it's in the plane, rotate it to get it right. This is what most OCHEMs will tell you. This is what the book is going to tell you. I'm okay with these things for now. Okay, so that's our first glance. So if it's in front, reverse it. If it's in back, take it as is. If it's in the plane, rotate it until you see it the correct way. Okay, so let's see how we do with this. So in this case, got to get my priorities right. First step, get your priorities straight. Okay, top priority, nitrogen, carbon, carbon, or carbon, nitrogen wins. We have an easy number 1. Now we got to consider a carbon with just H's, a carbon with an O, and a carbon with an N. So priority 1 with an O, 2 with an N, 3 there, but this is already 1, so this became 2, 3, and 4. 4's in back, so easy enough. Don't have to worry about anything, no rotating, take it as is. Clockwise would be R. This one, my H is in the plane, so I know it's going to be a little bit of trouble, so I have 1, 2, 3, and 4 for H. So 1 is easy, 4 is easy. And then ethyl is going to take priority for 2 over methyl, which is 3. So just like we did before, got to rotate it. So this H is going to rotate 2 and back. Rotate this 2 here and 1 over here. So then I've done that. Number 4 is in back. My circle is clockwise. So once again, we have an R center. And then finally, this one, number 4 is in back, so I said to take it as is. Priority 1 is bromine. Priority 2 is chlorine. Priority 3 is fluorine, and priority 4 is H. So 1, 2, 3, 4, 4 in back. So this time it is a counterclockwise circle, so it is S. Not bad. I would dare say so far it's so easy. Okay, so summary time. When number 4 is in back, and I arbitrarily put 1, 2, and 3 here. It could be 1, 3, 2, 1, 2, 3. I mean, could be whatever, but as long as 4 is in back, it's an as-is position. So when number 4 is in back, take the arc as is. Counterclockwise equals S. That's an S center. When number 4 is in front, then we reverse it. So 1, 2, 3 clockwise, but in this case, we reverse it. So as is, reverse, because it's in front. But here's the 0.001% that I want to tell you about. Okay, it comes down to third person versus first person. So let's go back to your hand example. If you look at your hand, you were the first person observer. So I gave you the traditional make an L, put your palms away, align it the right way, and everything's fine. You do something a little bit different. I want you to make a fist, and instead of your, when you make a fist, leave your thumbs out. So you know the thumbs up sign that people make that by curling all 4 fingers into a fist, by keeping your thumbs up. Now take your thumbs, it may hurt a little bit, but point them away from you into your page, and notice which way your fingers curl. With the left hand, you make a fist with your thumb pointing away from you, your fingers will curl in a counterclockwise direction. Your right hand, thumb pointing away, fingers curling, will rotate in a clockwise direction. You literally just made the rules of R and S with your hands. So by having a left and right-handed center, so your thumb points away from you just like in number 4, your fingers curl from 1 to 2 to 3, clockwise or counterclockwise. Counterclockwise S for left hand, clockwise for right hand. So in other words, your right and left hand just became your model kit. You don't need another model kit. So let's go through this really slowly, the rules that we just laid out. Your thumb equals 4. Your fingers curl. Only one hand is going to work, right or left hand. 1 to 2 to 3. Let's see if this works out. So let's take this structure right here. I'm going to put my thumb towards number 4, fingers towards 1. I recommend you do this with your right hand. So have your thumb up here. Fingers like this. So your hand should look something like that. You should be able to see your nails. Not saying they're painted pink, that's the color I happen to have. So start with your thumb towards number 4, your fingers towards number 1, and if it's a right hand or left hand, it'll curl naturally. If you have a left hand, then you wouldn't see your fingernails, and your fingers would curl out towards 3, that'd be incorrect. If you have a right hand, when you curl your fingers, it'll do something like that. So now with my thumb towards number 4 still, my fingers are curling naturally 1 to 2 with a right hand. Because this is a right hand that does this, it ends up right hand equals R. So let me get rid of everything that's in the way, because that's the most important thing there. If your right hand curls with your thumb towards number 4, if your fingers curl 1, 2, 3, it's an R center. This is by far the easiest way to get it in the plane. But in all my years of teaching, and yeah, first time I ever taught this was 1988, this technique, it's been a while. I will say that 1/3 of the people who do this get it instantly. They get it on the first or second try. Another third take about 5 to 10 examples, and they get it, they totally get it. And for a third of people, it ends up being just literally too painful. They'll end up in a sling or a cast, or they'll hurt themselves trying to do it in a weird way. So hopefully you're in the first group, you get it right away. If you're not, hopefully you're in the second group. Third group, we'll use other techniques. There are different ways to look at it. There's all sorts of other strategies and shortcuts that people will suggest, but none are as useful and easy as this one. The right and left hand rule for when it's in the plane. And I'll show you on really hard examples why it's so useful. Okay, so here we switch it up. 1 is now up here, 4 is here. So remember, your thumb goes towards number 4. So my fingers will be like that. And those are what I'm looking at. And looking at the back of my thumb. So if I do that with my left hand, so I've drawn a left hand now because I'm looking at my fingernails here, here, and here, and my thumb. I have my fingers towards number 1 and my thumb towards number 4. When I curl, notice when I curl, my fingers are going to go into the page. That's the wrong hand. That's the left hand isn't working. So I need a right hand. So with my right hand, now I'm looking at my palm. Notice here the little line that's I'm supposed to artistically represent a palm. So this is a right hand with my thumb towards number 4 and my fingers going up towards 1. It's not perfectly like that, but close enough. It's the best drawing we could have. So you're going to have to make a 109.5 degree angle between your index finger and thumb. If you do that and you curl, your fingers are going to come out towards number 2. So notice they're coming out in front of the page towards 2, and then going back towards 3. So it is a right hand that correctly does it. So because it's a right hand, means it's an R. Right hand equals R stereochemistry, left hand equals S stereochemistry. So the summary of the tricks as is, reverse, thumb, thumb. Actually, let me write it better. Let me put it where I'm supposed to. So the thumb method, the hand method, and the thumb hand method. Okay, I'm pushing this one hard. Once you master this, then there are tricks for when things are drawn in these structures that we can do. But I want to give you challenging ones. The reason the thumb method is so useful is because when you start getting things like chair conformations, it gets really, really tricky. So let's start with this right here. So this chiral carbon has 1, 2 coming up, 3 coming here. So we need to remember then that that's coming out. As long as I know that, then I'm in good shape. So I'm going to put my hand in a way. So here's picture. If you're looking at it, hopefully you see a palm. So match your hand to that, and hopefully it is a right hand is what you determine it is. That's just a weird part of the picture, so sorry, I'm getting rid of it. So there's the hand. Notice that the thumb is going this way, and the fingers are going that way. So I have the correct alignment. So when I curl, I'm going to curl up to the top of the page. That's where the 2 is. So now these fingers are starting to curl up. So they're starting to go like that towards 2, and then they come all the way back down to 3 and back. So that was a right hand. So because it's a right hand, it is an R center. Okay, so for this one, again, put your thumb towards 4, fingers towards 1. So I, again, have chosen a right hand. I start with the right hand. If it's wrong, then I switch to the left hand. So if you get into a habit like that, it becomes really easy. So there is a right hand. Notice that you have your thumb towards 4, your fingers towards 1. And when you curl, your fingers are going to go behind the page. So they're going to come back like this. So if I'm doing it right, it's going to curl back, come out to 2, we're coming out to 3. So your right hand is curling back and finishing like that. So when it comes back around, it is a right hand. Right hand equals R stereochemistry. So for chair conformation, you could try to redraw it, but the thumb method is great. So put your thumb towards number 4 and grab that bond. And if your fingers curl from 1, 2, 3, it's correct. If your fingers curl 3, 2, 1, or anything that isn't 1, 2, 3, it is incorrect. And I should be careful. It could be 2, 3, 1, 3, 1, 2. As long as you can say 1, 2, 3 when I count up, not 3, 2, 1. You're good. Okay, so let's look at one where we have actual atoms attached. So this carbon right here, priorities are 4 for H, 3, 2 for the O with just an H, 1 for the O in the ring. So 4 and 3, easy to get. 1 and 2, a little bit trickier. So 1 for the O with the ring, 2 up here. So my thumb should be towards 4, my fingers towards 1. I'm going to put my hand like that and see if I'm correct, if I'm going to curl correctly. So I'm starting with the right hand because that is my habit. I like doing this. So my thumb is towards 4, my fingers are towards 1. When I curl my fingers naturally with the right hand, they're going to curl down. If I curl down, I'm going to get the 3, not 2. So I have the incorrect hand. So I need to switch it up. So now I have my thumb towards 4, my fingers back towards 1. So they're kind of lined up. When I curl, my fingers are going to come up. They're going to go up to 2. So the shading is pretty bad, but hopefully you can barely see fingernails there. And it's going to come down to 3. So this time, if you match your hand to that picture, you notice your thumb is towards number 4. So that right there is your thumb. And your fingers are curling from 1 to 2 to 3, going back and around. So that matches. This is a left hand. Left hand equals S. Okay, let's go to the other chiral center here. 4 for H, that was easy. O for 1, that was easy. The 2 carbons, the ring carbon beats this. So methyl will be 3, ring will be 4, so, or 2, excuse me. So 4 for H, 1 for O, easy ones. 3 for methyl, 2 for the other. So again, I want my thumb towards number 4. I'm going to start with my fingers here. So I'm going to start with, again, I like to just start with the right hand. If it's correct, perfect. If it's wrong, I fix it later. So in this case, my thumb is going up. My fingers are going that way, so it's correct. When I curl, 2 is in front of me, so my fingers are curling out in front. So sure enough, it's following the right pattern. So it was, in fact, a right hand that matched. So this is an R center. So this would be S. This would be R. Hopefully this works for you. This is an amazingly useful trick. So once you get good at it, make it a little more advanced. So I was really anal about describing the orientation. Instead, so I'm going to say, put your thumb towards number 4 and grab it and like grip it. And if your fingers are curling 1, 2, 3, you grip with the correct hand. If your fingers are gripping it incorrectly, it's the wrong hand. So if I grip this carbon to 4 bond with my left hand, it goes 1, 2, 3. If I grip my right hand, it's 3, 2, 1. Identify it accordingly. This is one of the hardest ones to do. So you would have to redraw this into a dash wedge and then get R and S. The reality is it's just not worth it to do that. So I'm going to make the following recommendation. Thumb method, ta-da! So the priorities on carbon number 1, we have an H, which is 4, an O, which is 1. We have a methyl, and then the carbon behind us is ethyl. So 1 and 4, again, easy to get. This is 3, and then 2 represents the cone. So the cone is 2, the one in back. So my fingers should start towards 1, my thumb towards 4. So again, I'd like to start with the right hand. Hopefully it's correct. So I have my 4 going this way, my thumb going that way. And my fingers up towards, oops, sorry, I wanted to change color. I have my fingers up to here. So I have the right alignment. With the right hand, when I start curling, my fingers are going to go into the plane, which means it's going to go back to the cone one and back. So as I rotate it around, that is going like that. My fingers going like that. It's a match. Going in back before coming out to the 3. Right hand equals R. So if you grip it here, your fingers in a right hand will curl correctly. So this is an R stereocenter. This method, you can get RNS in 5 seconds at most when it's in the plane. And for a lot of the three-dimensional structures we're going to see, a lot of the massive molecules, this method is absolutely gold. It's absolute gold. It's just exactly what you should be doing. So I'm pushing this because you are now officially in the 0.001% category. People can actually do this method. Nobody will be teaching this. You will not find this anywhere. You will not see it written in a book. You will. The one book that I wrote years ago, put in there. It's a much better method to do it. And I will say when this starts showing up in other videos or other books, once this is released publicly, then it'll catch on. When people start seeing how easy this is, this number will go up. But for now, you're in a select group. Okay. So want to name chiral alkanes. So we're, again, not big on nomenclature, but I still want to at least address it to some extent. So this carbon chain 1, 2, 3, 4, 5, 6. So because of 6, I know it's got to be hexane. Set on that. And then my priorities, my numbering, I should say, of the chain. So it's got to be a 3-methyl hexane. So I'm feeling pretty good. Except now I have a chiral center. Priority 1, 2, 3, H and back. So this is an S. So this has become 3S. So all my terrible drawing, let me get rid of it all and say it is S3-methyl hexane. So with S in front, and at times the 3S is acceptable. IUPAC is pretty specific. I will not be specific when I test. If you're on the ballpark, that's going to be close enough. It is important. If you're writing papers, you're writing chemical documents, you really should be attentive to all their details. But I'm going to do it this way. But if you put 3S hyphen methyl hexane, you're fine because there's only one chiral center. When you have multiple chiral centers, then you have to be pay a little more attention to detail. You have to emphasize which chiral center is which. When there's only one, then S3 or 3S are interchangeable. Okay, this one is that case where we have 2 chiral centers, so we got to pay more attention. It is cyclohexane, so I know it's going to be my parent name. It has 1 and 2 for your groups, ethyl first alphabetically, methyl second, so it's going to prioritize as such. My priorities, my H is in front, so I'm going to reverse. This ring is 1, this side of the ring is 2, methyl 3, so 1, 2, 3 would be clockwise, but because H is in front, it's an S. And thumb method even works for this. When H is coming out, just put your thumb out. And if you curl with the left hand, it'd be 1, 2, 3 with your thumb pointing out. So even works there. For this one, priority number 1, H is in back. So priority number 1 is this ring, 2 is that ring that's there. So again, that's going to be an S. So notice we have to emphasize 1S, 2S, 1 ethyl, 2 methyl cyclohexane. I will be okay if you put 1S ethyl hyphen 2S ethyl cyclohexane, but this is when we start getting into IUPAC specificity. You have to put your chirality and then the IUPAC name. Okay, so far so good. So we were able to get RNS. Work on the thumb method. You watched it being done. You hopefully match your hand accordingly and you feel confident in it. But until you apply it, you really don't know it. Start with a few easy ones, just one single carbon compounds, but scale it up to really large biological molecules and discover how easy this is. So with that in mind, it is time to end yet another Toddcast. So thank you for joining, and I'll see you the next Toddcast. Bye.